Good evening, everyone. Hello, hello. There's no one live. Huh? Hello, Shillong. Hello. Is there anyone in Shillong? Two centers alive now. Perfect. Good evening, Shillong. How are you? How are you all at Shillong Center? I hope you all are good, right? And also, Diwali vacations are coming, right? So there'll be total of 2 or 3 days when there is no class. So meanwhile, what you can do is you can revise the previous chapter, right? Well, tomorrow there is a major test scheduled for tomorrow, right? That will be function, matrix indeterminate, and thirdly, integrations. So these main 3 chapters will be covered. But after that, I would say you can revise all the previous chapter also. Sorry, this is 11th, na? No, you don't have any major test. I thought it is 12th. Sorry. Shillong, who is the other center? Senapati. Okay. Shillong, Senapati, how are you, everyone? And please respond something, write something, so that I would get to know you guys can hear me. Shillong, if you have camera in your classroom, then please share your port number and also mark your attendances, all of you. All right. So how many students are there in Senapati? No camera. All right, Shillong, just let me know your attendance, both of you. So in the previous class, we have seen a couple of numericals over summation of, a GP, right? And general terms of a GP, then general consideration of 3 terms, 4 terms in a GP that we have covered, right? That was some 4 marks question we have also solved, right? You might have found those questions difficult, but of course I would say these are not like 1 or 2 marks, right? They are 4 marks, proper 4 marks. So, like you have to start the proper way, like how many terms consider in general. So A by R, A and A are like that, right? And of course there were like separating the factors, like how to factorize any raised to power 4 plus A square plus 1. You remember that R raised to power 4 plus R square plus 1. So all those kind of thing we have covered, right? Which are very important question in this particular topic, GP, summation of a GP. Is that clear, everyone? So now today we will see geometric means. Geometric means. Geometric means. Okay, on both 1 and 1. Sorry. So we should start now, right? And rest of The student will join us. What is geometric means? Again, as we have covered in arithmetic mean also, if there are two numbers given, let's say there are two numbers given, let's say A and B, right? If you insert some G, right, such that A, G and B, such that GM is called geometric mean between two numbers A and B. There were total two numbers in which we have find out their geometric mean. So geometric mean is called GM. In short, we call it GM. We would not write again all the time geometric mean completely. Okay. So GM is called geometric mean between two numbers A and B, such that A, small a, GM and this B are in GP. They are in GP. Is that clear? They will be in GP. Now, if they are in GP, so of course, G by A will be equals to B upon G. Ratios will be equal. So, from this we can generate that G square equals to AB or G equals to AB to the power half. AB to the power half. If suppose we have three numbers, right? If there are three numbers A, B and C, then their GM is going to be A into B into C to the power 1 by 3. Is that clear? So basically, if number was 2, right, A and B, so A into B to the power half. If there are a total of three numbers, let's say A, B and C to the power 1 by 3. So it will be 1 upon 3 this time. So whatever the number is, we will have that power, right? In general, what we can do in general, geometric mean of n numbers, let's say A1, A2 till AN is, what will be the formula? This GM would be A into A1 into A2, whatever the number we have considered, guys, A1, A2, A3 and so on. We will multiply all the given numbers, right? And will raise that power 1 upon n. So if this is suppose 2, there will be two numbers A and B. If there are 3, so this is 3 and 1, 2, 3, ABC. Is that clear? If suppose there are total of two numbers, 3 and 9, what is their GM? GM will be 3 into 6 to the power 1 by 2. That is how much? 3 into 6 to the power half. So that will be 36. No, it's not. It is 18 to the power half, which is how much? 3 root 2. Is that clear? So 3 root 2 will be the GM. Or hence I can also conclude that 3 root 2 and 6, they will form GP. Where it exactly came from, right? That the numbers and the GM will itself will make GP. Is that clear? Okay. as in the case of arithmetic means, there was what we were doing in the arithmetic mean, we were finding the average of all the given numbers. If suppose numbers are in n, right, n in numbers, so we were to add all the numbers a1 plus a2 plus a3 till an, and then we will divide with that particular number. Similarly, here in case of GM, we will be multiplying all the numbers and then we'll raise the power of 1 upon that number, 1 upon n. Clear? Simple topic, simple. We will also see the relation between AM and GM. So, very small topic, relation between AM and GM. Let A and B are two positive numbers, right? Then we have AM is greater than or equals to GM. Where what is AM, guys? AM is going to be A plus B by 2. What is GM? GM is going to be A into B to the power half. Right? A into B to the power half. Now, what we can have is that A plus B by 2 is greater than or equals to AB root over. Is that clear? So this you have to remember. This is very much important result. AM of any two or more than two numbers basically. I am defining for two numbers, but it is also valid for more than numbers, right? More numbers like 3, or they are 5 in numbers, they are 10, or any number of numbers, right? So always AM is going to be greater than the GM of these given numbers. Is that clear? Like we can do this question, inequality based question. And I would also suggest you to skip some 2 or 3 lines in between. Okay? Or you can write here, equality holds only when numbers are equal. That means AM will be equals to GM. AM is equals to GM, that means numbers are equal. A equals to B. Is that clear? Now, which kind of question you can expect is, you see, a very simple question. It says, if A plus B is equals to 1 and A, B both are positive, then find the maximum value of AB, right? This is question 1. Question 2 is find the minimum value of tan square theta plus cot square theta. Find the minimum value of tan square theta plus cot square theta. Theta belongs to R. Is that clear? So these are 2 questions. Let's understand how to solve this kind of problems, right? Involving A and GM. So AM is nothing but the summation part, right? Sum of two numbers, sum of three numbers, and so on. And GM is always the product part, right? A into B, suppose A into B into C. So in the first question, you see A plus B equals to 1, A, B both are given positive. So kind of this thing, when A and B are positive, whenever the given numbers or the concerned entities are positive, we can always think of, I would say even we should think of that, right? We should think of AM and GM whenever numbers are given positive. Because the thing is, guys, that this is very important. Let A and B are two positive numbers. Okay? So if numbers are positive, then only we can apply AM, GM. So this is a kind of hint for us that if A and B are positive, should we apply AM, GM? Yes, we should give it a try at least. So let's start with this. Let me consider those numbers are A and B. Now we have AM is greater than or equals to GM. What is AM of these two? A plus B upon 2. And what is this? AB to the power half. Now, what is A plus B given? 1 by 2 is less or equals to AB to the power half. Is that clear? So now, squaring both the side, it will give you 1 by 4 is less than AB. Right? What basically we have is that root AB is less than half. Is that clear? So if both are positive, definitely AB has to be less than 1 by 4. So this is the maximum value of A into B that they can possess. Is that clear? Hence, the maximum value of A dot B is 1 by 4. Yes, definitely I can scroll up. Is this part still long? The maximum value of A dot B equals to 1 by 4. Sir, how 1 by 4? Okay. So are you getting this thing that A, B, if we consider two numbers A and B and we apply AM greater than GM inequality, then we are good so far, right? We are good so far. I guess so. There is no doubt so far, I think, right? Everyone. But when you square on both the sides, what do you get? You will get AB and this will be square. See, basically this is given what? Root AB is less than half, right? This is nothing but root AB less than half. Now if you square on both the sides, what do you get? You will get AB is equal to 1 by 4. Basically, when you consider square on both the sides, so this will be AB less than equals to 1 by 4. Now, if I'm writing a very simple thing that x is less than or equals to 2, what do you understand? Is it the maximum value of x is given to? Is that true? What do you understand by this? If I am writing x is less than or equals to 2, x can take any value which is less than 2. X can take exactly 2, but x cannot take more than 2. So what we conclude is that the maximum value that x can take is 2. That means here, as we are getting here, this expression, AB is less than or equals to 1 by 4. So for any set of values of A into B, for any set of values of A and B where A plus B is 1, you will get the maximum value of A and B, that will be A dot B is equals to 1 by 4. Maximum, right? That means A into B has to be less than 1. I mean, a into b has to be less than 1 by 4. Maybe it can be 1 by 4 or 1 by 8, 1 by 7, anything. But the maximum it can purchase 1 by 4. Now I'll tell you how is it maximum value, and if we talk about exactly, right, exactly what is the maximum value, so that is going to be 1 by 4. A dot B equals to 1 by 4 will be when both the numbers are equal. When both the numbers are equal. Yes, definitely they are equal, because if A into B is 1 by 4 and A plus B is 1, so of course you will get A equals to B equals to half. I mean, this is not the answer, this is the answer, but I'm just telling you when we will get the maximum value. When A and B both are equal, then we will get the maximum of product. Is that clear, everyone? Senapati Silong. There is one more question, so you would have to try to understand the second part also. It says find the minimum value of tan square theta plus cot square theta. Senapati Silong, please tell me if you have any doubt. A simple use of AM greater than GM. Second is clear. Very good. Second is let numbers be tan square theta and the second number we take is cot square theta. Let numbers be tan square theta and cot square theta. Now again apply AM, GM. There is a very important concept that we will discuss, but for now let me come to this part. Tan square theta plus of cot square theta, right? So AM is greater or equals to GM, guys. Tan square theta plus cot square theta divided by 2 is greater than or equals to their product, tan square theta into dot cot square theta to the power half, right? Now we have to find out this summation. So let me write here tan square theta plus of cot square theta, and this is whole. As tan square theta, tan theta and cot theta, they are reciprocal of each other. If they are reciprocal of each other, so they will get cancelled when you multiply them. So in this side, this is all 1. So now this is 2 and this is 1. So tan square theta plus cot square theta, its minimum value will be 2. Minimum value of this summation is 2. Hence, minimum right? Basically, if something is, something like this, maximum is 2, minimum is 2. You have to understand this fact, right? Now, the important thing that I was about to tell you is that, like in second question, you guys should notice this. Numbers are tan square theta and cot square theta. So the reason we are directly applying AM-GM concept, because we know when we multiply these two numbers, tan square theta and cot square theta, as they are reciprocal of each other, so they will get cancelled. But if suppose one number was tan square theta and other is sin square theta, then there is no use of this kind of formula, because tan square theta into sin square theta. So there will be total of sin raised to power 4 theta upon cos square theta. Now you can raise some power, half power, right? So that will be sin square theta upon cos theta. But you cannot directly find out a relation between, the sum of two numbers and the number. The reason being, sum If this is not cot square theta, guys, then we cannot cancel these two. If we cannot cancel, then there will be some more theta's term. I hope you're getting it. Suppose this is tan square theta into sin square theta. Then there is no profit or use of doing this particular concept. Because in left side, that is up to us, right? If we consider tan and sin, so there will be tan square theta plus sin square theta. But you wouldn't get any result out of this. Is that clear? Say yes or no. This is very much important. All right, very good. Next is insertion of and geometric means between two numbers. Same topic as we have covered in arithmetic means. So be quick, okay? Be quick. Let's say there are two numbers A and B, and we have to insert n numbers such that they will make GP. I am naming these numbers as G1, G2, G3 till Gn. Right? This is Gn minus 1. Is that clear? So there are total of n geometric means between two numbers. As this is n and total 2 already present, so I would say total number of terms in this equals to total terms equals to n plus 2 now. Is that clear? Now please, in the last class also there was so many doubts, but I need to make sure that while writing now, you should understand that, right? So total of n plus 2 terms. Now, if I am saying this is, let's say, T1, okay, this is nothing but T2, this is T3, T4, it will be how much? It will be how much? B. Can you tell me what is B actually? B should be, of course, Tn plus 2, as there are total of n plus 2 terms. What is Gn? Gn is n plus 1 term. Is that clear, everyone? So guys, if this is T1, which is A, T2, which is itself G1. This is important, right? G1. G1, what is the value of G1? If common ratio is R, then what is G1? A times R. T3, 3 term, right? Third term, which is also G2. This is not important. T1, T2, T3 is not important, right? The destination is, of course, A, G1, G2, G3, finding all these values of geometric means. But the path is important. Path is nothing but the term. Which term is this? Is it T1, is it T2, is it T3, and so on. So that is why I am writing this time, that we be very clear about this. You should not get confused with T2 and G1. T2 is position of term as is it been located? I mean, it has been located on the second position, so that is the reason we are saying it as T2. But G1, first geometric mean. Clear? Now G2 is going to be A R square. T4 will be G3. So forget all this, T1, T2. This is just for reference, okay? You should focus on this part. G1 equals to AR, G2 equals to AR square, G3 equals to like this. Is that clear? AR cube. Now, very much important. If you are writing Gn, suppose Gn, nth Gm, right? Value of nth Gm will be AR to the power n. I hope you would understand. If what is term, that will be n minus 1. Sorry, n plus 1. Anyway, T n plus 2, the last term, right? This is first term. This is last term. That will be B. which is V, right? As in terms of series or pattern wise, I can write this as a r to the power n plus 1. G1 is one term after a, so it will be a into r. G2 is a into r square. Similarly, B is n plus 1 term. Right? Is that clear? So that will be a into r raised to power n plus 1, the same power. Here, B equals to a r to the power n plus 1. So r raised to power n plus 1, I can write b upon a. So r equals to v upon a to the power 1 upon n plus 1. This is nothing but the value of r, what you have considered, right? So now I think, can you tell me the answers for G1, G2, G3 and so on? You just have to find out the r value, right? Where b upon a, b and a are the first and last terms, of course, given to you. And n is nothing but the number. Like if I say insert 3 numbers or 3 GM between these two numbers, so n will be 3 then. We have understood this in AM also. Let's do some question. Question is, insert three numbers, insert 3 numbers between 1 and 256 so that the resulting is a GP. Insert 3 numbers between 1 and 256 so that the resulting is a GP. I think question is clear. It is demanding for GM, finding 3 GMs which will be inserted between 1 and 256. Is it clear? Right? So the main important task is, we know that G1 is going to be AR, G2 is AR square, right? G3 is AR cube. We all know this. Important is, what is the value of R? So how we find R? We have a formula, right? We have a formula. Formula is B upon A, 256 upon 1 to the power 1 upon n plus 1, which is 256 to the power 1 upon 4. If you find out this value, this comes out to be 4. So if R equals to 4, guys, what will be the answers? 4, 16 and 64. This is the answer. Any doubt, anyone? In case of AM, if you remember, value of the common difference was B minus A upon n plus 1. Here it is B upon A to the power 1 upon n plus 1. Things are quite same. We got it? So what is AR? AR is, A is the first term and R is the common ratio. So as you know, first term is A, then second term will be A into R, then the next term is going to be A R to the power 2, right? Take your time, take your time. I think we have to take one more class for summation in sequence in series. right? Sum of n terms of a specific series. Miscellaneous. In the next class, we will cover all these miscellaneous series, right? Today, we will finish entirely GM, GP, and all of this. It is nothing. It is nothing. Forget it. It was, I'm talking about AM, not GM, right? It was just revision from AM, from last class, I think. There we were defining D, small d. Here in case of GM, we define R, common ratio. In case of AM, we define common difference. Right? Okay. Okay, I think now you can solve this kind of problem, right? Summation and all things. There is a very important kind of segment, I would say a question, but right? Let me write the question. Find the sum. Find the sum. S equals to 5 plus 5 plus 5, 5, 5 plus 5, 5, 5, 5, and number of times it will be increasing. N terms. Find the sum of these n terms. How would you find the sum? Anyone? Any hint on this? Tell me. Anyone? Any hint? How would you find out this series? Okay. So before this, 5 plus 5, 5 plus 555 and so on. Maybe you are not able to do this, but let me give you a very smaller, very easier one. Right? Maybe you can find it out. Series is S equals to 1 plus 1, 1 plus 1, 1, 1 plus. No, not as in formula, not as in formula. Okay. Can you find out this series 1 plus 1, 1? 4 times 1 plus 5 times 1 plus and so on. Or can you find out this series 9 plus 99 plus 999 and so on, right? Tell me. Any idea about this? 1 plus 1, 1 plus 111 plus 1111 plus and so on. Okay, there is a specific method to solve this kind of problem. So there is all set of problems we are going to cover. I'll start from the last one, you see, which is very important because it's the basic of this kind of structure or this kind of formula pattern. Now you see, I'll take this as to solve first, then I'll come back. Okay. Suppose the problem is S equals to 9 plus 99. So how we would find this answer, this summation? Now can I write this S equals to 9? Can I write this 9 as 10 minus 1? 99 is 10 square minus 1. 10 cube minus 1. Yes, it makes sense. It makes sense, right? Last will be 10 raised to power n minus 1. Is it clear? Basically, this is 999. You can write this as 1000 minus 1. What is 1000? 10 raised to power 3 minus 1. If it is 9999 4 times 9, then it will be 10,000 minus 1, which is 10 raised to power 4 minus 1. I hope you can understand by this. Any of these 2 or 3 numbers, you will understand the rest of the pattern. Is that clear? And once you will get this, you can always notice the upcoming GP series now, right? Summation of GP, which is 10 minus, you see, 10 plus, sorry, 10 square plus 10 cube. If I club all these powers on 10, it will be this one, right? It will be this thing. And how many 1 we are subtracting? Minus n. Because these are n times. So 1 into n will be 1 plus 1 plus 1 plus 5, suppose, 5 times, right? So 1 plus, and so on. Till 5, it will be 5. 1 plus 1 till n times. So it will be n, right? Now what is this sum? General, we know that 10a r raised to power n minus 1 upon r minus 1, because r is the common ratio, which is 10. So what we are getting this sum as? This is, I can say, one of kind of answer. Rest depends on which kind of options are given to you. Accordingly, you have to solve it. Like you can multiply with 9 and can take LCM into the denominator, right, as 9, and then 9 and 10 you can multiply in the bracket. Is that clear? But the important thing is this: how we are approaching to 9. We can write 9 is 10 minus 1 and all these given numbers, because it is an institution. It is an intuition that 10, 100, 1000. These are nothing but the GP itself. Why we are converting into this particular form is that because they make a GP series, and always subtracting minus 1 is an easy task. So 10 plus 100 plus 1000 will make a GP. So we can apply the formula of n terms, or how many terms are there accordingly. Sum of GP with common ratio is 10. It should be 1. Where exactly 1? What you are saying, Silong? It should be 1. Okay. Yeah. Thank you. Fine. See, this is the correct thing, na? But it's still fine. Thank you. Yes. Thank you, Silong. I got it. I hope this is clear to everyone, right? So now, if direct series, which is starting from 9 plus 99, you can do this. Or I would say, if you can remember, you should remember this. If not, that's totally fine. Nothing to worry about. Next is when you have to find out 1 plus 1 plus 1 and so on, right? Now, of course, you can write this as 10 plus 1, right? 1 is 1 itself. 10 can be written as 10 plus 1, 1000 plus 1, and so on. That you can do. Let me write here first. First of all, what you can do is that 1 plus 10 plus 1, 100 plus 1, sorry. It's not 100 plus 1. You have to apply this particular form that, if 1 plus 11 plus 111 is given. So guys, what you will do is, you will create, or you will try to create this form, which is 9 plus 9 plus 999. Because we have seen that if numbers are in terms of 9, we can always write this. So what I can do is, let me multiply with 9 and divide with 9. Right? Okay. Now, if we take this 1 upon 9 as outside, and if we take this 9 in the numerator inside, then this is nothing but this summation. Is this clear? And now you see, once you will convert this any given series into 9 plus 99 and so on, you can plug in this formula now. So what is the answer? It will be 1 upon 9, 10 raised to power n minus 1 upon 9 minus n. This is nothing but your answer. I hope you can understand. Clear, everyone? This is we have started with. This is the basic root, I would say. Okay. This is one application where we are changing the given 1 plus 1 unit into 9 unit, right? Now, lastly, which I was talking about initial, the very first question was 5 plus 5, 5. If it is not 1, if it is not in 9, it can be any of like 8 plus 88 plus 888 plus and so on, 7 plus 77 plus, or 5 plus 55, or right? So here we will discuss now the very first one. If S is 5 plus 55 plus 555 plus and so on. Again, n terms. Okay, guys? N terms. So now again, ultimate, motive is that we have to convert this into 999, 999. Is that clear? Now, you should do always, right? You have to do this always. You will take 5 out. And when you do this, you will get 1 plus 1, 1 plus 1, 1, 1 plus and so on. Is that clear? If you take 5 outside, there will be only 1 plus 11 plus 1 and 11 and so on. Is that clear? Now, we just have understood how we convert this. For this, we multiply with 9 and we divide with 9. So, multiply 9 will be multiplied with 1, 1, 1. Is that clear? Now, we remember, as this result is always 10 raised to power n minus 1 upon 9 minus of n. This is the answer. So first of all, you have to remember 9999, that series, right? And how we get this 1111, that is also important. We are dividing with 9 and multiplying with 9. And then in general, if we have any of the number like 2, 3, 4, 5, 6, 7, 8. Okay? Now please ask me your doubts. This is also important, how we are taking this 5 common and what is the thought behind we are multiplying and dividing by 9. So that is the reason I have already covered this. And before that, right? So in series, easy, moderate, then the toughest one. Now if any doubt, let me know. No doubt, Silong. Very good, Silong. What about Senapati? Senapati, do you have any doubt? If not, you can do this question. Question is, what exactly doubt in that? Senapati, exactly which part? Sorry. Question is, find this sum. 0.15, 0.015, 0.0015, total of 20 terms are present. Second is, rest you can solve with the NCRT. I mean, from the NCRT you can solve. Senapati, what I can do is, I'll repeat it one more time, okay? Till then, you please try to solve this question. Silong. There is a sum given, 0.15, 0.015 and so on. You have to find out this sum where total terms are present 20. Now you please, Senapati. We are coming back to this. Okay. So now this is quite same as we were doing in case of AM, where two numbers were given, right? A and B. The first term and the last term was given. And we have to insert some n numbers in between these two, such that they will form GP, they will form AP, right? So accordingly, they are named GM and AM. Now, if there is total of G1, G2, G3 and till Gn, there are total of n geometric means and two terms already present. So how many total terms in this series? N plus 2. Now this is n plus 2 and I am taking CR as R, common ratio as R. That is not given to us. What is given to us? We have understood that A will be given, B will be given and value of n would be given. So this is the formula of R. How we are getting that? We are comparing the value of B, or we are comparing these two. The last term B, in the formula of AR raised to power n plus 1 from this. Is that clear? Try to solve this now. Okay, now problem is this, S equals to 0.15 and so on. So let's identify first of all, right? What is 15 into, 0.15 is what? 15 by 100, 15 by 1000, 15 by 10,000 and so on, right? S equals to, now let me take 15 common, right? 15 common. So what we get is 10 raised to power 2, 10 raised to power 3, 10 raised to power 4 and so on. (15 common). What is 1 upon 10 square? 10 raised to power minus 2. What is 10? 3 minus 3, 10 raised to power minus 4. Can you tell me what will be the last term if I have to write in terms of power? That will be minus 22. Because minus 2 is having, minus 2 is with the first term. Minus 2, right? The very first term. So what will be the 20th term? Plus 2. Sorry, not plus 2. It will be 21 actually, not 22. Okay? See, when this is first term, minus 2 power. When this is second term, minus 3 power. So if this is 20 term, it will be minus 21 power. Anyway, that is not important. Total terms are important. I'm just writing here to let you know that how we get any kind of last term or any general term by looking at the first two terms. First some 2 or 3 terms. Is that clear, everyone? Now, of course, this is a GP. What is the common ratio? Common ratio is 1 upon 10 or 10 raised to power minus 1. So let me write the summation now. 10 raised to power minus 2 a r raised to power n, r raised to power n minus 1 upon r minus 1. Is this clear, everyone? Seems to be very tough, but this is what is true, right? R equals to 10 raised to power minus 1, A equals to 10 raised to power minus 2, and total number of terms are 20. So this is nothing but the formula of GP with all this data. Clear? Now, summation will be, if you can rewrite it, please. That would be great. This is 1 upon 100. This is 1 upon 100. This is how much? 10 raised to power minus 20. Minus 20 minus 1 divided by 10 raised to power minus 1 minus of 1. Is that clear, everyone? So if you want to solve this, you can solve this further. But as there is no option given, so nothing to worry about the final answer. This is also the final answer. Or you can convert 1 upon 10, right? This is 1 upon 10, then you can multiply it, cancel something. Is that clear? Please ask me if you have any doubt. Plus minus 1, correct. I'm not getting you exactly. What is plus minus 1? Say long. At the same time, plus 1 and minus 1. Please, what is plus minus 1? Next is spatial series. Spatial series. And your homework for this week will be, I'll say this, don't worry. Homework is plus upon minus 1. What is plus upon minus 1? That is minus 1, right? That is direct number. If you're writing plus, I mean, I'm not getting exactly plus slash minus 1. I'm not sure. Okay, so you are saying, sir, plus 1 or minus 1. No, that is not both of the answer, right? Something else. When you will solve this, that is definitely not 10 raised to, plus 1 or minus 1, right? That will be something else. You have to multiply with 15 also, don't worry. I mean, you cannot forget this 15 thing. Anyway, guys, if you're getting it, then please solve 9.3 if you have. Those who do not have, don't worry. I'll share after the class the complete 9.3. 9.2 we have already covered. Right? I have shared in each and every group. I hope that you all have attempted all the questions from 9.2. Now you will do 9.3 because you have 3 to 4 days gaps. Right? 9.3. I'll share on the group. Spatial series. Now, we have covered AM, AP, GM, GP. Now there is one more HP, HM, but that is not in your syllabus. So we will not cover that part. But there is very special segment called spatial series. Spatial series means the series which we'll talk about, these are not like AP or GP where difference will be same or their common ratios is same. No, that is not the case. They are spatial because of some specific pattern or the approach, formula approach, or I would say how to solve these kind of problems. They make them spatial. Okay. Now, apart from this, while solving these spatial series, you will require some basic formulas, like what is the sum of initial and natural numbers, first and natural numbers. What is the sum of first and natural number, their square. Let me write it. So very important spatial series, first one. S1 equals to 1 plus 2 plus 3 plus 4, sum of first and natural numbers. We are denoting as S1, that is n into n plus 1 upon 2. S1 I am writing for 1 power. This is also same as if I were to write this. Understand, okay? R, sigma R, where R is varying from 1 to n. You have to understand this, because now you are in class 11th, you are preparing for JEE, so most of the time will not be given this, 1 plus 2 plus this all thing, right? But they will use some sigma operator. And then you have to open it and you have to solve it. Sigma on R. Now what is the argument on the sigma operator? That is R. How R is being changed? 1, then 2, then 3. And what is the sign in between? 1 plus 2 plus 3 plus till n, the last. Is that clear? So whether this or whether this is given to you, answer will be this. N into n plus 1 upon 2. Is that clear? This is important. Next is second. We are writing as S2, which is 1 square plus 2 square plus 3 square and so on till n square. So S2 is n plus 1, 2n plus 1. It is n plus 1, 2n plus 1 divided by 6. Or S2 equals to sigma R equals to 1 to n R square. N into n plus 1, 2n plus 1 divided by 6. This is what S2 formula is. Third, S3, which is 1 cube plus 2 cube plus 3 cube. You just write all the formulas and we will see question on these formulas also, don't worry. This is n into n plus 1 divided by 2 to the whole square. Right? Which is also same as S1 square. So we have this relation that S3 is S1 square. Anyway, important for you is this formula. These are yellow marked, all are these the formulas. These are all formulas for S1, sum of all the natural numbers, first and natural numbers. This is sum of squares of first and natural numbers. S3 is sum of cubes of first and natural numbers. As this formula is coming out as n into n plus 1 upon 2, so as it is the structure, the same formula for S1 also, we have this relation. We have this relation, very much important. S3 equals to S1 square. Is that clear? No, I should not fill this. Sorry. Please, tell me if you are done with this. Now we will study for more 10 minutes and then I'll leave. Okay. Today we will have only class from 4 to 5:15, right? Yes, take your time, Silong. Don't worry guys, don't worry, just take your time. We will do just some basic question to understand the formulas, to revise, to memorize all these formulas. In the next class, we will do some advanced problem, okay? Miscellaneous problem from NCERT also. What is this sum? 1 plus 2 plus 3 plus till 15. First, so answer will be 15 into 15 plus 1 upon 2, 120. So 120 is the correct answer. Right? Why? Because n equals to 15. In this formula, as one formula, we have to put n equals to 15, and as there are total of 15 terms present. Okay? N equals to 15. Second, 1 square plus 2 square plus 3 square and so on till 10 square. What is the answer? We will put n equals to 10 in the formula of S2, which will be what? N into n plus 1 into 2n plus 1 upon 6. All right, 10 into 11 into 21 upon 6. So this is how much? 2, 3, 2, 5, 3, 7. So what we get is S equals to 35 into 11, which is 385. So 120 is the answer, 385 is the answer. Okay, similarly you can do for S3 also, so same formula application part. But let me do this question, this is quite nice. S equals to, suppose, 6 square plus 7 square plus and so on till 20 square. How you would find this answer? 6 square plus 7 square till 20 square. Tell me, how would you solve this? Okay. Let me give you some hint. Always remember, guys, always remember, 1, start with 1, right? It can end for any value of n, but it should start with 1. Always remember, first n natural number, right? Whether it is square, whether it is direct summation or cube summation. Now we are starting with 6. So what I can do, I will add 1 square plus 2 square till 5 square. And similarly, I will subtract here. 1 square plus 2 square till 5 square. This way, there is no difference in these two. By doing so, what we have done is, now we can apply the formula over this. Now we can apply formula. Is that clear? Because it is now 1 square plus 2 square, continue, right? Continuing till 20 square. So 20 into 21 into 41 upon 6 n into n plus 1 into 2n plus 1 upon 6 minus of n into n plus 1 into 2n plus 1 upon 6. Now you can solve it and you can find out the answer. Is this clear, everyone? So always remember, if your series is not starting from 1 or from any some number, any natural number, then what you have to do, you have to add and subtract the rest of numbers so that you can plug in the formula. You can use that formula. Right? So whatever you are adding, you have to subtract the same thing. Is that clear? Yes, I'll repeat, definitely repeat. See, the actual question is this, right? 6 square, 7 square, 8 square till 20 square. But in this question, I mean the given figure, I cannot apply this formula. I cannot apply this formula, right? I mean this formula is not valid here, right? Is not valid. The reason? Because the series is, this series formula or this summation formula is always valid only when series is starting from 1. As it is starting from 6, so we cannot apply this. When we can apply? Now, if I have this 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus 6 square plus 7 square plus 8 square till 20 square. Now it has been completed. But if you have added, so you have to subtract also. What you have to subtract? The same thing. Okay? The same thing. Now what is, guys, what is this summation, this total summation? This one. What is this summation? This one. N equals to 5. This is N equals to 20. Tell me if you have any doubt, anyone. Okay. Very good, everyone. So this is for the day. Okay, and your homework will be 9.3 as per now. And I'll give you some more question, right? But on priority basis, you have to do 9.3. Please, everyone. I'll share this screenshot of all the questions given in 9.3 of NCERT. Those who have already, please start solving. Those who do not, I'll share on the group. All right? So everybody has to do it. They're very much important for boards also. Okay? Is there any doubt in any of the things which we have covered today, starting from AM, GM, insertion, series? Please. Silong, Senapati? No doubt. Silong. Very good. What about Senapati? Senapati, what about you guys? No doubt. Very good. Okay. That's great. So everyone, there will be total of 4 days off, 3 days off. So please do it seriously, right? There is no class for 3 to 4 days. Why? Because of Diwali vacation. So everybody, happy Diwali, everyone, and be happy. And what would I say? Do not play as much as firecrackers. If you are playing with that, please do it carefully. Okay? Firecrackers are not very good for your health. I mean, all these gases, all these acids. You are not on holiday. No, it is. You are not aware of them. Of course it is. Tomorrow is no class, and after 2 more days there is no class. Anyways, happy Diwali, everyone. Happy Diwali. Well, that's a great festival, full of lights. Okay, so stay safe and be happy. And play a safeful Diwali. Wishing to all of you and your families. Now we'll see you in the next class. Till then, take care. Good night, Senapati. Thank you. Same to you. Welcome. Okay, bye everyone. Bye, take care.